All right, gentlemen, we're looking at 4.1, day 1 of 2. First question is asking us to determine a simplified algebraic expression. And the word simplified just means that we want to collect like terms so that our final answer is in the most simplest form it can be, with no further like terms to be added, subtracted, or what have you. Okay, so we're looking for the area of the shaded region between the two rectangles. Well, let's first look at the outer rectangle. If I want to find the area of that, it's like a rectangular donut, basically, right? We have a large rectangle, and then we're going to cut out this middle portion from it afterward and figure out what's left. So one way I like to do this, if you want to organize your work, is we'll do like the area of the larger. So I'll write A equal area, right, for L. A is area, and the L stands for the larger rectangle. And the formula for area is just length times width. And then we're also going to calculate the area of the smaller rectangle, which is also length times width. So what do we have for the larger one? We have the length is 3x plus 5 times 4x. I know we like to write the 4x on the left, but just because I'm going to show you, we can switch it up. It doesn't really matter. If I write 3x plus 5 here and write the 4x on the right, again, I know we're accustomed, a lot of homework questions, textbook questions have the distributive property happening from the left, but distributive property is multiplication. And so what's really happening here is you have multiplication, whether it's happening from the right or left, it doesn't matter. So 4x times 3x and then 4x times 5. We know 4x times 3x is 12x squared. And then the 4x times the positive 5 is 20x. And we're done for that part. The smaller one in the interior is 2x times x minus 1. So we'll distribute 2x times x is 2x squared, and the 2x times negative 1 is negative 2x. So we've calculated the area of the larger, we've got the area of the smaller, and we need to find the area between the two. So we have to subtract the area of the smaller one from the area of the larger one. And I'll point to a common mistake that'll happen. A lot of students, to find the total, just put a subtraction sign right here and go ahead and say 12x minus 2x is 10x, and 20x minus 2x is 18x, and I'm done. And that's a big mistake, because what you have to remember is that, and I'll put a subtitle here, is total of, let's say area of a shaded region. Let's do that. Area shaded. Okay, it's gonna be 12x squared plus 20x minus, and you have to put brackets here. We're taking away 2x squared minus 2x, because what are we subtracting? I can even put brackets around this first binomial. What you have to remember is that we're subtracting a 2x squared, but we're also subtracting a negative 2x, and subtract negative means addition, right? So you have to picture it this way, and don't forget there's an invisible 1 there. So when we write this now, we could drop the brackets. That's 12x squared plus 20x, and here it becomes minus 2x squared, and then plus 2x. I'll just put that in red to highlight it so you understand. That's probably the most common error students will make. That's plus 2x, because we're subtracting not just a monomial, but we're subtracting a binomial. So no matter how many terms you have, you're subtracting that from the area of the larger. And now we can collect like terms. So we've got this 12x squared minus 2x squared, which is 10x squared. And we have the 20x plus 2x, it's plus 22x. That, my friends, is the total simplified area of the shaded region. Okay, we can't go any further unless the question asked us to solve for the length or width when x is, and give us the answer, give us the value of x. Okay, the learning goal for today is basically learning how to solve an equation, which means solve for the variable that makes the statement true. So if I have, for example, 3x equal 15, then the value of x here would be 5. A value, right, divide both sides by 3, and x equal 5. I've now solved that equation. The value of 5 for x makes that true. 3 times 5 is 15. Okay. The second statement here we have for the learning goal is to solve a one-step equation, isolate the variable by performing the opposite operation. And you're going to hear me mention that soon. If we had, I just did that here. When we had 3x equal 15, we have multiplication happening between the 3 and the variable x. So we use the opposite operation to isolate the x. We divide by 3, 3 divided by 3. But if we divide the the left side of the equation by 3, we have to divide the right side of the equation by 3. We know 3 divided by 3 is 1, but it's bad form to write the 1 in front of the x. So we leave a numerical coefficient of 1 invisible. And that's that x equal 5. Okay, so we used opposite operation. We used division to get rid of the 3 times x. In a two-step equation, there's more than one term on a side. You might have a binomial, you might have 3x plus 1 equals 16, something like that. And then you have to add or subtract, which I like to call switch teams, change jerseys, and then isolate the term. Okay, so let's take a look. This asks us to solve by inspection. That just means do it by eye. Okay, that's telling us that 3 times a number is 45. What is that number? X would have to be 15. You're used to saying divide both sides by 3, and that's maybe how you solved it by inspection. But this is one of those knee-jerk reaction, math gut, look at it, I should be able to figure that out. So this is telling us that -5 plus a number is equal to 9. What does that number have to be? If I have -5 plus that, well, then the total answer will be +9. Well, we know -5 plus 5 is 0. That's the 0 principle. But we need to get to +9. So it's going to have to be 14. There you go. M is 14. Okay, now they want us to solve. In this case, we're actually going to use some of our learning goals, okay? So we have -3x minus 25 equals 0. It would be nice if we just had the 3x by itself here, or -3x by itself. But we got this minus 25 business that we have to deal with. If we have minus 25 here, if we add 25, then we can add 25 on this side. Or some of you like to pretend you take this -25, switch teams to the right side of the equation team, and change it to +25. That works, okay? However you like to think about it, that works. We know -3x minus 25 plus 25, that means that the 25 is gone. We're left with -3x here and a positive 25x on the right. And now our question looks close to the one that we had here when we solved by inspection. We have to divide both sides by -3. You don't have to show that step for me, but just to show you, we're dividing both sides by -3. -3x divided by -3 is positive 1x. And on the right side, I'm left with, so I think a little squished here. We shouldn't have that going under the equal sign. That should be moved over a little bit. And let me erase that, do that properly. That should be over here. And so my final answer is -25/3. It doesn't matter who gets the negative, either or, right? The fraction 25/3 is negative. And the question said leave our answer as a fraction when necessary. Well, this time it's necessary because we can't simplify any further, can't reduce that fraction. 25 is not divisible by 3, so there we go. That's our final answer. For the next question, the simplest thing to do here is when you have fraction equal fraction is to cross multiply. You might have been taught in elementary that's called the butterfly method, but it's just cross multiply. So the numerator x multiplies by the denominator invisible 1 on the other side. X times 1 is x. And then the -5 times 6 is -30. Done. That's a pretty quick and easy way to do it. But I do want to show you one other thing. If we're using opposite operation, like our learning goal said, what's happening to my x right now, right? Here in this question, the x is being multiplied by 7. In the last question, our x was being multiplied by -3. Here, our x is being divided by -5. Well, what's the opposite of division? Multiplication. So if I multiply by -5 here, I'll multiply by -5 there. But that -5 multiplication cancels out, is the opposite of dividing by -5. So I would be left with x equal -30. Either way you want to show your work, if you cross multiply, there's a lot less writing, and multiplying both sides is exactly the same thing as multiplying both sides by -5 is exactly like cross multiplying. All right, here we have a couple of steps to do. We have this -9. So we're going to add 9 to both sides, or I'll show a different way of doing it this time. We're going to switch teams, change jerseys, so that we have 7x equal 11, and that's going to be +9. So it looks like the -9 disappeared from the left and just showed up on the right with a positive integer. So it changed signs, or I call it change jerseys, right? So we have 7x is equal to 20, and then we divide both sides by 7. Again, you don't have to show this division part. For me, you could just write x equal 20 divided by 7, and that's our final answer. Okay. So that's that. Get to the homework, and we'll see you in class. Take care.